Okay, ladies and gentlemen, here is how we're going to proceed today. My computer died literally twice during the middle of recording. Turns out it was a power supply issue, and I am now after school recording this lesson for those that were missing it. So I'm going to keep it brief because there's not actually a classroom here. I'm going to seem like a crazy person to anybody that walks past and sees me teaching to an empty room. I am going to show you how to do domains when you have a function inside another function. All right, so first of all, let's talk about putting one function in another. Not finding a domain yet, just how do we do this? By the way, your homework worksheet is going to say f(g) of x, and that means the same as this, f of g of x. It's like the f function is a big fish and swallowed the g function, like a little fish is inside the big fish. So I take the f function, which is right here, and I write it out. And then I replace the x with a big empty spot because this f function is going to swallow the g function. The g function is right here, and we put it into the other function. So now it's x squared minus 4 goes right there. That is the one function in the other. That is f of g of x. Now, how do we find its domain? All right. First of all, you can look at this and say, oh, this thing has no limits on its domain because it's all real numbers. There's no square roots, there's no fractions, and therefore I don't have to worry about it. But you can't do that because the domains for these depend on the domains they give you in the first place. So these are not implied domains. These are actually given domains. So sometimes they could call it a defined domain, or they could call it a artificially restricted domain. There's a whole bunch of things they could say. But that's the domain. And this is the domain for the g function. So how do I find a domain of something where there's a function inside another function? Well, you need a formula, and here's the formula. You would need to do the domain of the inside function. In this case, the inside one is g. It doesn't always have to be g. That could be f of p of x, for instance, and then the inside function would be p. But this time, the inside function is g, and so we're going domain of g intersected with, I wish it was as simple as domain of f. It's not, because then it would just have to be this intersected with that. I draw both number lines, see where they overlap. It's not that easy. Because this is a function in a function, we now need to go the g function, g of x, the inside function, in the domain of f. Now just look at this. If it was just these two, that would be if we did add, subtract, or multiply these functions. And we just have to overlap the two parent domains, no big deal. But when it's a function in a function, notice we have to have this part where that function goes into the other domain. All right. To keep from having a long explanation on that, I'm going to stop there and say that is our formula that we have to follow. So let's just kind of do the prescription here. It's domain of g, which is what? It's right here. It's x is greater than or equal to 1, intersected with g of x in d of f. Here's g of x, and I'm going to put that into the domain of f. The domain of f is x is less than 5, so I got to put this into that. So now I've got x squared minus 4 needs to go into this, and I say that is then less than 5. You get how this used to be an x, and I put x squared minus 4 in it? All right, now I'm going to solve that, and I would add 4 to both sides. X squared is less than 9. Now I'm going to square root both sides. Square root, and x is less than 3. Oh, no, it's not. The absolute value of x is less than 3 because we did the square root of a variable right there. Now, I'm going to split this into my two answers. X is less than 3. Oop, not less than or equal to, just x is less than 3. And x is less than negative 3 is a common mistake because we had 3 here. If we change this to a negative 3, that's like multiplying by a negative. So our sign needs to switch. Did you catch that? This is x is less than 3 and x is greater than negative 3. Whew, all that has to intersect with this one. So now I like to put them on a number line, and I see it the best that way to see where they overlap. And x is greater than or equal to 1. Here, let's put 1 on our number line like right here. And greater than or equal to 1 goes that way. Okay. Next, x has to be less than 3 and bigger than negative 3. Well, here's 3, and x is supposed to be less than that. And here's negative 3, and x is supposed to be bigger than that. And where do these two overlap? They overlap between 1 and 3. And it doesn't work at 3 because it's an empty circle here at 3. So it's between 1 with a bracket on it and 3. So my final answer, between 1 with a bracket on it and 3 parentheses. That was my domain for these two functions, one inside the other. Now you might think, since this is just having them reversed, you know, the f is now on the inside, that it'd be just super simple. Nope, we got to do the whole thing. I'm going to start by showing you how the formula would look now. Remember, it was the domain of the inside one, so now it's domain of f intersected with not as simple as domain of g, but domain of g goes over here, and it's f of x in domain of g. All right, so what's the domain of f? Domain of f is x is less than 5, intersected with f of x. F of x, I'm going to go up in here now and put f of x, which is this guy right here, into the domain of g, which is right there. And I'll end up with 5x plus 1 is greater than or equal to 1. Subtracting 1 from both sides, 5x greater than or equal to 0. Divided by 5 on both sides, x 0 divided by 5 is still 0, greater than or equal to 0. Now if I put these on one number line answer, I got x is less than 5, here's 5, and x is less than that. And x is bigger than or equal to 0. I can do this all at once. Here's where x is 0, bigger than or equal to 0, and that's where they would overlap right in there. I could have made two separate number lines and saw where they overlapped, but that would be it. So I'm going to say from 0 to 5 with a bracket on the 0 and a parenthesis on the 5. Is that the same domain as this? Not even close. All right, so there's a couple example problems of finding the domain of functions that are inside other functions. And that's the main meat of what I taught today in composition of functions. So I'm now going to look at the homework with you real quick. I'm going to pause for a second while I do that. Okay, and in my classes, here's how I had you start. I felt like there were too many problems on tonight's homework for one night, so we crossed off all of these. And then on this first page, I didn't need you to find the domain for each, because that would be a whole separate calculation for each problem. It would take you a long time. So the next page, it depended on the class, to be honest. Some classes I had them skip some, but on other classes I had them skip all. Frankly, right now I'm going to save time and just have you skip that problem. Then over here, on this one, on number 13, since this is going to be all real numbers and that's going to be all real numbers, the domains aren't real creative, so all real numbers and all real numbers will just come out with all real numbers. So I'm going to have you cross off that one. On these that are left, I had kids find the domain here and find the domain here, find the domain here, and this one was interesting. Find the domain when you have the inside function is the same as the outside function. Let's see if you can figure that one out. All right. So note here, the domain is given right there. The domain says for the f function that x is less than or equal to 10. So you got to use that for the f domain. So if I was going to do this problem for an example for you, number 16, I'm going to do g of f of x, and I'm going to say that would be, first of all, f of x function is right here. And that got eaten by the g of x function. The g of x is this guy. I make it fairly big so I can fit the other one in it. And then g of x eats f of x, and f of x is 3x minus 5. There we go. And there is my combined function right there. Now what's its domain? It's the domain of the inside one, which is f, intersected with f of x in the domain of g. So this is domain of f, which is given right here. X is less than or equal to 10, intersected with f of x, which is 3x minus 5, put into the domain of g. Wait a minute, they didn't give me a domain of g. Well, then I have to do my domain myself. It's called an implied domain. It's implying that x has to be greater than or equal to 0. So I'm going to put this into that right there. So that becomes 3x minus 5 is greater than or equal to 0. Add 5 to both sides. 3x is greater than or equal to 5. Final answer, x is greater than or equal to 5/3. And now if I just intersect that and that, I will have my answer. So to finish it up, here's a number line for you, where if this is 10 and this is 5/3, then x is greater than or equal to this, and x is less than or equal to 10. It's like that, and there we go. That's number 16, part A. Remember, the domains, I just had you do the ones on the outside here, and then also this one here. So, okay, then for the last page, these are important. You got to understand how to do this. This means g of f of 1, and these aren't that hard. What's f of 1? I go to the f graph, and that's an input of 1, which is this, gives me the point 1, 2. That means the output was 2. So f of 1 is equal to 2. So this becomes 2. And now I'm doing g of 2. Okay, the g graph's over here. G of 2, that's an x input of 2. That's right here. Follow it up. It's right here. 2, 3. And now if I put in 2 into the g function, I get a 3. So the final answer is 3. Okay, that's an example of how to do that kind. And that's all I got for you for today.